Democritus was born in 460 BC and died in 370 BC. Atoms cannot be destroyed, differ in size, they differ in shape and temperature, they are always moving, and they are invisible. His exact theory was that all matter consists of invisible particles called atoms. Atoms are indestructible. Atoms are solid but invisible. Atoms are homogeneous. Atoms differ in shape, size, mass, position, and arrangement. Solids are made of pointy atoms. Liquids are made of large, round atoms. Oils are made of very fine, small atoms that can easily slip past each other. Democritus made the first atomic model. Aristotle was born in 384 BC and died in 322 BC. He believed that everything was made of water, fire, earth, and air. For 2,000 years, everyone believed Aristotle's theory. But now we know that everything is not made of water, fire, earth, and air. Antoine Lavoisier was born in 1743 in Paris. He named carbon, hydrogen, and oxygen. He established that water is a compound of hydrogen and oxygen. He discovered oxygen's role in combustion and respiration. He also discovered that sulfur is an element. And last, he helped the transformation of chemistry from a qualitative science to a quantitative science. John Dalton was born September 6, 1766, and died July 27, 1884. An element is one of a kind. All atoms of an element are identical. All atoms that make up the element have the same mass. Compound is one of a kind substance due to different elements bonded together. All elements differ because of different masses, and they aren't easily separated. Compounds have fixed ratios of atoms. Each atom has its own weight. This creates a weight ratio between elements. Chemical reactions involve rearrangements of combinations of atoms. Everything is an atom. All atoms of different substances have different weights. Joseph John Thomson, or J.J. Thomson, was born on December 18, 1856, and died on August 30, 1940. J.J. Thomson discovered electrons. He also discovered that atoms can be divided. And last, he discovered atoms are made of positive cores and negatively charged particles within. This is his plum pudding model.
In 1909, Robert Millikan measured the charge of an electron. He did the oil drop experiment to do this. What he did was that he observed tiny charged droplets of oil between two horizontal metal electrodes. In 1911, Ernest Rutherford established that the nucleus of an atom was very thin, extremely small, and positively charged. He did the gold foil experiment. He shot a beam of alpha particles at a sheet of gold, and the few particles were deflected. From this, he developed a model of the atom, which had all the protons in the nucleus, and the electrons were around the nucleus. In 1923, de Broglie discovered the wave nature of an electron, or wave-particle duality, which is the idea that light and subatomic particles can behave both as waves and particles. His hypothesis about electrons having wavelengths was confirmed by the Davison-Germer experiment. In this experiment, electrons were fired at a solid crystal, and the electrons would reflect off the crystal, and they were analyzed. In 1932, James Chadwick discovered neutrons. Using alpha particles, he discovered a neutral atomic particle with a mass close to a proton. He then named this particle the neutron. Chadwick put a piece of beryllium in a vacuum chamber with some polonium. The polonium emitted alpha rays that hit the beryllium. When the beryllium was struck, it emitted neutral rays.